linear equations when you have three variables. So with these, this is where our systems start to become a little more complex. So we need to pay attention to each of these steps. And then really the key to these is just practicing solving these types of systems to where you start to understand the steps more naturally. So to solve linear systems in three variables, we need to first start by rewriting the linear system as a system with two variables, okay? We can do this using the elimination method, but I'll also show you an example too, how to do this using the substitution method. Next, you will just solve the new system, which will have two variables for both of its variables. Then you'll substitute both of those answers into one of our original equations to solve for the variable that we eliminated in the first step. Okay, finally, you can check your final solutions by substituting each of those values into any of our three equations. Okay, so I know this is a lot to digest right now, but once we start going through the steps, hopefully all four of these steps make a little more sense. So let's start with example 1 here. Okay, so obviously we have linear systems with three variables here, and we have three separate equations. So we need to first look at how can we eliminate one of these variables, x, y, or z. You can do this for any of them, but for this purpose, let's go ahead and start by just eliminating our x values. So in order to eliminate our x values, we need to break this up into two separate parts. We need to do an elimination using our top two equations, and then elimination using our bottom two equations. So don't pay attention to our third equation for now. If we were trying to eliminate x from our top two equations here, we would need to multiply our top equation by -2 so that our x's cancel. So let's go ahead and do that. Remember, distribute -2 to all of our terms. So we have -2 times x, which gives me -2x. -2 times +2, which would be -4y. -2 times -3, which would be +6z, equals -2 times 50, which would be -100. Okay, now copy down our second equation exactly how we have it. 2x plus y plus 2z equals 3. Okay, so since our coefficient on our x values are opposite signs, all we need to do is to go ahead and add -2x plus 2x. Obviously, these are going to cancel each other. -4y plus y gives us -3y. 6z plus 2z gives us 8z. -100 plus 3 gives us -97. Okay, so if we were to just look at our top two equations here, we have now eliminated our x variable. So you can tell our equation that we're left with has a y variable and a z variable, right? Those two variables which we know how to solve a system with two variables. So let's go ahead and do this with our bottom two equations here. Obviously, our coefficient on our x variable are the same. So all we need to do is subtract them or multiply one of these two by -1. So we'll just do that. So that gives us 2x plus y plus 2z equals 3. And then multiply -1 by our bottom terms, minus 2x plus 5y, -1 times -5y, -1 times 4z would be minus 4z, equals negative 1 times 79, which is just 79. So once again, our leading coefficient here is opposite signs, so we can go ahead and add. Our x values will once again cancel. Y plus 5y gives us 6y. 2z plus negative 4z gives us negative 2z. 79, which is 82. Okay, so now that we have completed that step with eliminating our x variable from our top two equations and our bottom two equations, we are left with two equations with just our x and y variables. So that is step number one. So step number two is we need to solve the new system for both of its variables. So let's go ahead and do that. So we have our system, which would be negative 3y plus 8z equals negative 97. And then our second equation, 6y minus 2z equals 82. So now that we have our new system, we need to go ahead and use either substitution or elimination. Let's stick with our trend of elimination here, which we're just going to say we eliminated x's to show that's what we're doing in this example. But anyways, let's keep going with elimination. To get we can do either our y variables or our z variables here. But to get our y variables to eliminate, we could multiply our top equation by 2. So that our negative 3 and 6 would cancel. So let's go ahead and do that. We have 2 times negative 3, which is negative 6y. 2 times 8z, which is 16z, equals 2 times 97, which is negative 194. Okay, our second equation stays the same. So we have 6y minus 2z equals 82. Since our leading coefficient here has opposite signs, let's go ahead and add. That will cause our 6's to cancel. 16z minus 2z equals 14z. Negative 194 plus 82 gives us negative 112. So go ahead and solve for z. All we need to do here is divide by 14. And that gives us z equals negative 8, which is one of our three variables. Okay, so finding our first variable is the most difficult part. Now that we have one of our variables, we can't go ahead and substitute that into our original equations yet because we would still have two variables and we'd have to solve a whole nother system. Yet, if we were to substitute that into one of our two equations here that we solved for in our first step, we could solve for y. So let's substitute our negative 8 into our second equation here. So that would give us 6y minus 2 times negative 8 for z equals 82. Now we just go ahead and solve. 6y, negative 2 times 8 gives us 16 equals 82. Scroll down just a little bit. Subtract our 16 from both sides. That gives me 6y equals 66, which would give us y equals 11. Okay, that is our second of our three variables. So now that we've solved for x and y, we really can't do much more with the system that we eliminated for in our first step. So we're going to have to use one of our original three equations. To make things easiest, let's use our top equation since x does not have a coefficient besides 1. So let's substitute into that equation there. So we have x plus 2 times y, which we know is 11, minus 3 times z, which we know is negative 8. Let's try that again. Equals 50. That may be cut off for you guys. So let's go ahead and solve. That'd be x plus 2 times 11, which is 22. Negative 3 times negative 8, which is 24, equals 50. Go ahead and solve here. We got x plus 22 plus 24, which is 46, equals 50. So that gives us x equals 4, which is the last of our 3 variables. Okay, so now our job is to write this as an ordered pair. When you're writing a 3 variable system like this as an ordered pair, I would prefer if you guys would write it as x, y, and then z. Okay, that is just the standard for writing our solutions. So we have 4 for x, 11 for y, and negative 8 for z. And that right here is our final solution. Okay, so I know these problems are a bit tedious, yet if you break down each of the steps individually, none of the math is overly complicated. It is just a lot of steps. Okay, and like I said before, the only way you guys are going to get questions like this down is to practice them on your own and then check your solutions. Okay, so for number 2, I would advise that you guys pause the video here and give number 2 a try on your own. Once you've completed it, you can play the video and I will work it out. We will save the questions on the backside for class. Okay, so in number 2, we're going to use a slightly different method. We're actually going to try and use substitution. To help solve for our 2 variable system. So to use substitution, instead of eliminating our x from our original equation, let's just use substitution with our first linear equation here. X plus 3z equals negative 5. Okay, so let's solve this equation for x. So let's subtract 3z from both sides, which leaves us with x equals negative 3z minus 5. Okay, since we have this equation set as x equals, let's substitute this into our second equation here. So we have 5 times x, which we know equals negative 3z minus 5 minus 2y equals negative 22. This is just our second equation. So let's go ahead and simplify. Remember here, you would have to distribute. So that gives us 5 times negative 3z, which is negative 15z. 5 times negative 5, negative 25, minus 2y equals negative 22. Okay, from here, go ahead and simplify. Let's add 25 to both sides. So that gives us negative 15z minus 2y equals 3. And then in order to write it the same as our bottom equation here, let's just switch places with our z and y variables. That's negative 2y minus 15z equals 3. Okay? So this is the equation that we're going to use for step number 2. Okay? Because then if you look at both of our starred equations here, they both feature a y variable and a z variable. So that can take us to step number 2 where we solve our new system for both of our variables. Okay, so let's rewrite both of these up here. We have negative 2y minus 15z equals 3. And then our second equation, 5y minus 6z equals 36. Okay, now let's solve using substitution. If I'm looking at our coefficients on our y variables, we have 2 and 5. So a common multiple that these would have would be 10. Okay, so in order to get to 10, we must multiply our first equation by 5 and our second equation by 2. Okay, let's go ahead and do that. 5 times negative 2y gives us negative 10y. 5 times negative 15 gives us negative 75z equals 5 times 3, which is 15. In our second equation here, we have 2 times 5y, which is 10y, 2 times negative 6z, which is negative 12z, 2 times 36, which gives us 72. So now at this step, let's go ahead and add in order to eliminate our y variables. Negative 75z plus negative 12z gives me negative 87z equals 15 plus 72, which is just 87. So let's go ahead and solve for z. Divide negative 87. That gives me z equals negative 1. Okay, once again, we've solved for our first variable, z. So now we can go ahead, and since we have a little bit more of a mix here, we can really use any equation to solve for our missing term. Okay, so let's start by solving for x. Let's use our original equation right here. So we have x plus 3z, which is just negative 1, equals negative 5. Okay, x minus 3 equals negative 5. So that ultimately gets us x equals negative 2. Okay, now that we have both our z and x variables, really doesn't matter what equation we use as long as it includes y. So let's use our second equation here. 5x minus 2y equals negative 22 and solve for y. So we have 5x, which would be 5 times negative 2, minus 2y equals negative 22. 5 times negative 2 gives me negative 10. Negative 22. Go ahead and solve. Add 10 to both sides. Negative 2y equals negative 12. Okay, divide both sides by negative 2. That gives us y equals positive 6, which is the third of our variables. So now go ahead and write your answer. Remember, you write x first, which is negative 2, y second, which is 6, and z last, which is negative 1. Okay, so like I said, we will save the second half of these notes for class. I know these notes are a bit tedious and a lot to comprehend initially, yet we will spend many days working on these linear systems, and just make sure that you are, attempting each question and bringing questions that you have to class. Thanks for watching.